Hey guys, today we're going to be looking at going a little deeper into factoring polynomials. Um, Before we start really truly factoring polynomials, we're going to practice something that's going to make factoring them a lot easier. So we're going to what's called factor out the greatest common factor for a polynomial, and we'll see what that means shortly. So just a quick reminder about distributing. Here we have a quadratic trinomial being multiplied by a monomial. This is just one factor. So what we can do, and what we usually symbolize with these little curves here, is we know that when we're distributing, this type of setup means that we can multiply this 2x by each individual term. So 2x times 3x squared is 6x cubed plus 2x times 6x is 12x squared plus 2x times 12 is 24x. So that was just a quick reminder about how we distribute. What we're going to be doing now, when I say finding and factoring out the greatest common factor, I mean given this, we need to be able to write this sort of thing. So let's take a look. So basically what we're doing is we're going to be undistributing. We're going to be sort of pulling out the greatest common factor. So let's see what we can pull out. So we want to find the greatest common factor of these two terms. Yesterday we looked at it a couple different ways. Let's look at it by listing. So I'm just going to kind of write them out like this, maybe on top of each other. And as you guys get better and better at this, you will almost never have to actually do this. But just to see how it works, just to get a nice foundation, we're going to just do it for now. So I'm going to write out the prime factorization of 15x to the fifth. Well, the prime factorization of 15 is 3 times 5. And then x to the fifth is x times x times x times x times x. And then the prime factorization of 12 is 3 times 4. X cubed is x, x, x. Now what we want to do is we want to find the common factors. So we know that they have a 3 in common, just 1 3. 5 and 4. 12 is not divisible by 5, and 15 is not divisible by 4, so we're not going to count those. And then they do have an x in common, and they have another x in common, and they have another x in common. So this is what they have in common is what's going to be on the outside of these parentheses. So I'm going to go ahead and make a set of parentheses. And we're going to write this on the outside, 3x cubed. We would say that 3x cubed is a factor of both of these terms. But now we want to write what's left over. We know it's going to be separated by a plus. And what is going to be left over is all the stuff that we sort of crossed out. So for this, what's left in place of 15x to the fifth is now going to be 5x squared, because that's all that's left. 5x squared. And then for our second term, we have 4, and that's it. Just 4. There's no x's left. So this is actually our answer. When we have to factor something, when we have to factor out a greatest common factor, that's it. So we can always just double check it by seeing if it multiplies out to the same thing we started with. So 3x cubed times 5x squared. Well, 3 times 5 is 15, which we got there. X cubed times x squared is x to the fifth. 3x cubed times 4 is 12x cubed. So we're good. Let's try another one real quick. So 7x y squared plus 21x squared y squared. So let's see here. I'll do this kind of the same way. I'll try to do it a little quicker. So 7y, y, y, and we have 21 is really 3 times 7 times x, x, y, y, x, x, y times y. So let's pull out, find our greatest common factors here. Well, we got 7, we got 1x, and we got both y's actually. And then what's left over there? Well, nothing's left over up here, so that'll be interesting. We have a 3 and an x that are left with that 21x squared y squared. So let's write our parentheses. So let's write what we got outside first. So what do they have in common? They have 7xy squared. 7xy squared. All right. Now, we need to write something in place of this 7xy squared. Well, it looks like 7xy squared, we took everything. So we're actually just going to write a 1. We need something there. Some people might say we'll put 0, but if we were to multiply this back out, we want 7xy squared times whatever's in here to be this term. So that's going to be 1. And then what's left over here? Well, 3 and x, and that's it. So 1 plus 3x, we can multiply that back out. 7xy squared times 1 is 7xy squared. Positive 3x times 7xy squared is 21x squared y squared. So we are set. That's all that we can pull out. Let's try one more, then an example for you guys. So this is a bit of a longer one. Let's see if I can do it without writing out everything. So I'll try to just talk you through kind of what I do. Some of you may have already noticed sort of a pattern with the variables. We are just finding the lowest power of each variable that we can pull out. So in this case, I know I'm going to pull out an x cubed because I can't pull out x to the 4th and I can't pull out x to the 5th. And I know I'm also going to pull out a y, only one y. So I might as well write that now. X cubed y. And of course, if you need to write out by stacking these like we did in the previous problems, you can totally do that, no problem. We can also factor out a negative from each of these terms. I know that seems a little different, but they're all really multiplied by -1. Now I'm going to see what I can multiply. Let's see. This is divisible by 12 and 2. Maybe I'll write the prime factorization. 12, 2. 12 is really 4 times 3, which is really 2 times 2 times 3 times 2. Okay. 40 is 4 times 10, which is 2 times 5. 4 is really 2 times 2. So if we were just doing 24 and 40, we could pull out a lot. 2, 2, 2, we'd be pulling out 8 if it was just these two terms. But let's see what we can get out of this 10. So 10, we have 2 times 5, and that's it. So let's see what they have in common. Well, we got a 2, and a 2. This one's only left with a 5. Is there a 5 in this one? Yes. Is there a 5 in this one? No. So all we can pull out is 2. So we have -2x cubed y. And then let's see. We need a monomial that when it's multiplied by this term right here will give us this. Well, we know it's going to be positive because it needs to come out negative times a positive is a negative. What do we need to multiply 2 by to get 24? That's 12. What do we need to multiply x cubed by to get x to the fifth? That's x squared. What do we need to multiply y by to get y squared? That's just y. Next term, we know it's also going to be positive because we already sort of pulled out that negative. What do we need to multiply 2 by to get 40? Well, that's 20. What do we need to multiply x cubed by to get x to the fourth? Well, that's just x. What do we need to multiply y by to get y cubed? That's y squared. Again, we're going to have a positive here. What do we need to multiply 2 by to get 10? Well, that's 5. What do we need to multiply x cubed by to get x cubed? Well, nothing, just 1. And what do we need to multiply y by to get y? Well, just 1. So we're not really going to write that 1 since we already wrote the 5. I mean, it would be kind of weird to write 5 times 1. So we're just going to write 5. I'm going to move that parenthesis in a little bit. And that is our answer right there. And you can double check it with multiplication by distributing. And I just got a couple problems for you guys to do. These two will be the problems that I'd like for you guys to practice tonight. Make sure you can do these. You're ready to go for tomorrow. We'll get some more practice then. See you then.